Hey guys, welcome to this session. Our topic is thermocurrent electricity. This is our new topic where we'll be discussing simply about the thermocurrent electricity, that is current electricity due to heating. Now we'll start with the electromotive force, that is E.m.f, and the potential difference, that is PD. We'll begin with the concept of these two, electromotive force and the potential difference. I hope you get them well and you understand them. So let's see the concept of electromotive force, E.m.f, and the potential difference, plus some common terms that are in this thermocurrent electricity. We'll start with the potential difference, PD. Simply, this PD is the difference in the potential between the two charged points of the conductor. So the difference that can be observed between the two charged points of the conductor is what we call the potential difference, that is PD. And it is measured in volts with the SI unit, that is volts, with the unit V. The potential difference between the 2 points, it can also be defined as the energy converted from electrical to other forms when a current of positive charge passes between the 2 points. Now you can obtain this by saying that V equals to W over Q, whereby V, that is the potential difference, W, that is the work done, that is in driving the charge between the 2 points, Q is the amount of the positive charge. So you can get the potential difference by taking the work done in driving the charge between the 2 points upon the amount of the positive charge. Let's see the electromotive force, E.m.f. E.m.f, this is the voltage developed simply by any source of electrical energy. Take an example such as battery or dynamo. It is generally defined as the electrical potential for a source in a circuit. It is measured in volt with the same unit, that is V. Electromotive force of a source, this simply just the energy that is converted from the non-electrical to the electrical form when 1 coulomb of positive charge passes through the source. Now, it can be obtained by saying E equals to W over Q, where E, that is the E.m.f, electromotive force, W, that is the work done by the source, Q, that is the amount of the positive charge. They all look alike, comparing these to the E.m.f and the PD. Now, you have to note that there can be E.m.f without a closed circuit, but there can't be a potential difference without a closed circuit. So simply can say that we need a closed circuit to obtain the potential difference, but it's not necessary for the E.m.f. Let's see further common terms in this thermocurrent electricity, that is the internal resistance. It can be abbreviated as small letter R, is an opposition offered in the batteries or power supplies, which has an effect of reducing the output potential difference as the current supplied increases. So it's just kind of a resistance, or can say the opposition that is given by the battery or any power supply, which can have the effect of reducing the output of the potential difference, or simply PD, as the current supply increases. Resistance, abbreviated as capital R, is an opposition offered by the resistor to the flow of an electric current. You can obtain this from Ohm's law. We've already discussed the previously in other videos, where you can say that the R is equal to V over I, voltage divided by the current. Resistor, this is simply a component that has a resistance in it, or you can say it's an instrument used to oppose the flow of current. While a variable resistor, you can say rheostat is a resistor whose resistance can be changed in order to change the current flowing. And the symbol for this variable resistor, as you can see there, that's how variable resistor can be shown in the various circuits or in the electrical appliances. Resistance box. This simply consists of a number of resistors that are connected in series through thick brass plugs. That is, any of the resistors may be short circuit by putting a plug into associated socket. So that's how simply a resistance box looks like. There are those resistors of various numbers that can be plugged in, and you can observe them simply in this resistance box, how they work. Wire resistors, these are the lengths of wire of non-resistance. The resistors used in electronic circuits are the ones that are made from the carbon or metal film, and the value of the resistance is shown by the color-coded links. You can observe them in the various electrical appliances. So these are just few of the common terms in this thermal current electricity. I hope it's clear, guys. Thank you for listening. We've observed and discussed the concept of EMF and the PD, and we've seen the various common terms in the thermal current electricity. Thank you.